The oldest known computer is a Greek device that works with gears that are programmed to calculate astronomical phenomena. It was made 22 centuries ago, somewhere in Greece. Since its discovery, it is in the National Archaeological Museum where you can see it today. This ancient computer that works with gears is programmed so that it shows all the astronomical phenomena known at that time. It is very fragmented, as we can see in this showcase, because it was for many centuries in the sea. This automaton is like a clock with two faces. It has a clock-like phase with two pointers of the sun and the moon. And the circular dial is divided in two rings. One is really a map of the sky with the zodiac, the names of the zodiac, and the other one is a calendar based on the sun with 12 months and 365 days, with an additional day added every fourth year. On the other side, we see several scales that are related to lunisolar calendars. For example, we see here a 19-year period called the Metonic cycle that is based on the phases of the moon and the solar year, and is one of the Greek traditional calendars. It defines also the beginning of the Olympic Games and other Greek festivities like the Isthmian Games, the Nemean, the Nan, the Pythian, and the Aleian. This astronomical computer predicts eclipses, lunar and solar. Every predicted eclipse is mentioned with the actual hour of the day it will appear, and of course the month and the year in a period of 18 years and 11 days and 8 hours, or even better, in a period of 54 years and 1 month. We have studied the surface of this ancient device using three-dimensional photography. With mathematics and physics, we can illuminate appropriately the surface and have an interactive photograph that we can study in our laboratory, illuminating in the way we prefer, and to see all the details of the object. We can even take off the rust of the object using mathematics and physics. The most important results came from X-rays, radiographies, and especially from computed tomography. The ancient computer works with gears that perform the appropriate mathematical calculations to show, for example, the position of the sun or of the moon for any desired time, and also the phase of the moon, and possibly the position of the planets. In this way, using the gears, one can program this ancient computer to perform the necessary mathematical calculations and to show with pointers like this one, for example, here, or the other one over there, the position of the moon during the time, or of the sun and the phase of the moon. The design of the gears and of the mechanism in general is really astonishing. Knowing the exact position of the gears and the number of teeth, we can work out the mathematics that the designer has used to program this ancient computer. This is the gear of the sun from a tomography. The moon that we see here goes around the Earth, that is here at the middle, with a variable speed following Kepler's second law. This is programmed using two circular motions that the designer of the computer adds together to have the correct position of the moon with the variable speed as it happens really in the sky. And it shows that the moon has a faster speed when it is at the perigee and a slower at the apogee. This instrument has a manual that describes all the functions of the mechanism, and it also contains the laws of physics that they use to predict the phenomena that it eventually shows. For example, here we have the laws of physics they use to predict the phases of the moon, and here is the law for the eclipses, lunar and solar. Here we can see the map of the sky with the zodiac at this part, and there is another ring here with a calendar very similar to the present one based on the sun, with 365 days and an extra day added every 4th year. And right here we can read instructions concerning the exact use of the device so that you can have a proper calendar. For example, if the Pleiades, let's say, are rising together with the sun, or if Eagle rises in the evening, and so on, we know that it is that day, let's say the 10th of October or the 20th of October, and so on. And in this scale, exactly here, we can see an example of a lunar eclipse that happens at 9 o'clock. So this sigma for Selene, the moon, and here hour, ora in Greek. And the number 9 here tells us that during this month, of course, at full moon, we will have a lunar eclipse at 9 o'clock. And incidentally, during the same month, we have a solar eclipse that will take place at 9 o'clock. This machine is designed and, in fact, works following the doctrines of the philosophers that we call Pythagorean. Nature can be described and predicted using mathematics, using the laws of physics, and of course, using causality. And there are even ancient poems that describe these sort of things, like the celestial law that puts the stars in their position and motion. Who made this mechanism? We don't know, of course, but we know that 3 similar devices have been constructed by the great mathematician and engineer and physicist Archimedes. Archimedes constructed 2 celestial spheres that were automatic, and as Cicero tells us, these machines gave the position of the sun, the moon, and the planets and their motion in a very realistic way. So they were similar to this mechanism. As Archimedes lived a century before the construction of this mechanism, can be ruled out as the actual constructor of this machine. But at that time, 21 and a half centuries ago, Hipparchus at Rhodes is the most important Greek astronomer, and we know that he has constructed many machines, and also in the machine of Antikythera, we have discovered the actual method that Hipparchus uses, adding 2 circular motions to calculate the position of the moon. So Hipparchus is possibly the constructor of this ancient computer. This ancient device has been found in a huge shipwreck that probably sank around 60 to 80 BC. And it was full of Greek treasures taken by the Romans to Rome and other places in Italy. This machine has been discovered in an ancient shipwreck by sponge divers in 1900. The red circle shows the position of Antikythera, exactly here. At the bottom of the sea, the divers discovered a huge treasure, very important, with many statues made of marble and copper, and loads of olive oil and wine, perhaps amphorae, transported to Italy. The so-called ephebe of Antikythera is one of the most beautiful Greek statues discovered, in fact, in this shipwreck. Another very impressive statue is the philosopher of Antikythera. Many very beautiful glasswork has been discovered in this shipwreck, like this very beautiful bowl. And another very impressive sofa used for symposia discovered in the same shipwreck.